At-risk offers several different time series models that we can choose from. So if you go to time series and define, you'll see there are categories of models available. Okay, so we have GBM. So GBM is geometric Brownian motion models. Okay, and don't worry about the complex name. It's a fairly simple concept. Here we assume that the variable, the value of the variable between consecutive periods is independent. So the variable between consecutive periods is independent. That is, what happens in time period t is independent of what happened in time period t minus 1 or t minus 2 and so on. So in other words, it is not, there is no autocorrelation. Okay, and then the second assumption is the change that happens from the previous time period and the present time period has a normal distribution. Okay, and that's something to be verified. So because of this independence, it's often called random walk models, because at any time period t, independent of what happened in t minus 1 backwards, the value is determined. So it's independent of what happened previously, so it is called random walk. Then we have ARMA. AR stands for auto-regressive and MA stands for moving average. And often you will see a REMA model, which is autoregressive integrated with moving average. So you can combine both. So again, we can have the autoregressive model by itself with the time difference lags, different lags. Same here, moving average. And then combining AR part and MA part. So that would be the integrated model. A REMA is what it's usually called. So here it assumes that the data is autocorrelated, unlike GBM. So it's autocorrelated over time, so which means the value of the time series in period t is proportional to the value in time period t minus x, okay, where x can be 1, which means it's correlated with just the one period before it, or it could be t minus 2, t minus 3. So usually when you have trend, that correlation will be very strong with t minus 1, a little bit less strong with t minus 2, a little bit less strong with t minus 3, and so on. So the autocorrelation with different lag will decline if there is trend. So that's why when you graph the autocorrelation with different lags, if the autocorrelation gradually goes down, that is indication of trend. And another aspect of autocorrelation in this fashion, going back, that is considering different lags, is if there is seasonality, then there will be high, strong autocorrelation when the lag is equal to the number of seasons that we consider. So if it's quarterly seasons, then the values with every 4 quarters lagged will have high correlation because it is the same season at that particular lag. So if you look, in a quarter, if you look for autocorrelation and there is autocorrelation every 4th period, then you see that there is quarterly correlation, provided that you to see whether there is autocorrelation, quarterly autocorrelation, then you aggregate the data in a quarterly fashion and see whether there is strong autocorrelation every 4 periods. If you want to test whether there is monthly seasonality, then you aggregate the data on a monthly basis, compute your autocorrelation, see whether there is strong autocorrelation with lag 12, lag 24, and lag 36, and so on. So first you have to aggregate the data according to the seasonality that you want to test, and then prepare autocorrelation, look for strong autocorrelation at that lag. And then we have two variations of ARCH. Okay, so that is autoregressive conditional heteroskedasticity. The AR stands for autocorrelation, and then heteroskedasticity, and then a variation of that is GARCH. Okay. It's similar to ARMA, except that here we are going to assume that, well, not assume, if the data exhibits variations that change over time. So change of the time series is a function of the previous deviations from its long run mean. So the deviations that occur, okay, if the band of fluctuations changes over time, then that's what heteroskedasticity refers to. So it's a variation of ARMA model. So these are the three models, or three categories of models that at-risk has in its time series fitting, and within each class of models there are some slight variations, so we won't get into those. So we have other parameters to consider as well within each general class of time series, which will be like, what is the periodicity for, is it one, do we lag one period or two periods, and seasonal patterns. And then we can also look for sudden changes, large jumps in the value, and those jumps gradually diffuse, and as we saw the example in air travel, revenue paying mileage RPM after and before 9/11, which was a kind of a defining moment. So those are the kind of the aspects that we need to deal with, which at risk is not going to automatically fit. And besides these, you can have expert opinion. If you rely only on expert opinion, purely based on expert opinion, then no analytical, empirical analysis is necessary. But usually you will have a hybrid approach where you will have empirical analysis, and then you use the empirical analysis in combination with expert opinion to come up with your final forecast for the future.